Hi, welcome back to my channel. Today I'm going to show how to climb on any object in Unreal Engine's game animation sample. Don't forget to smash the like button to get new awesome tutorials every week. The first thing you'll have to do is open the character's blueprint, then the try traversal action function and go to this part. Then delete this part which gets the ledge transforms by using a specific actor. We're going to replace it with a more advanced version. Delete this part, recombine this hit result, and create a branch. Create a new function and call it Try Traversal Action All. You want to add two input pins, one called Hit Result and one called Traversal Result Check. This inputs are going to be type Hit Result and Traversal Check Result respectively. Both of the pins have to be passed by reference so we can modify them. Create another function and call it Calculate Ledges. Create a pin and call it Hit Result with Hit Result Type 2. Don't forget to pass it by reference. Then connect it with the other function and open it again. Now we can start designing the algorithm to do the magic. Promote this pin to a local variable called Initial Hit Result, and then create a new function. Call it Nudge Trace towards Object Origin, and create a pin to connect it to our variable. After that, break the Hit Result variable and promote the impact normal to a new local variable. Cache another float variable as trace length. This will be the sphere radius of our hit component's bounds. Now get the hit component's up vector and do the dot product with the actor's up vector. Get the sign of the product and multiply it by the hit component's up vector. Promote this to a local variable and call it Object Absolute Up Vector. This step is made in order to be able to climb objects, even if they're upside down. Now let's complete this function. Set the hit result by reference. Break it from both the start and the end of the function. Get the hit component's bounds and project a point from the component's origin to the impact point using the impact normal. Then get the unit direction from this point to the impact point and subtract the result from it. For the next step, we're doing a sequence with 4 execution pins. These will be 3 larger parts of the function and 1 just for returning the final values. On the first execution pin, create another sequence and then create a new function with both 3 input and output pins. The name of the function will be Trace Corners, and the inputs and outputs will be respectively a hit result, a trace direction, and the trace length for the inputs, and the offsetted corner point, a close to corner Boolean, and a distance from corner for the outputs. For the inputs of the function, get the hit result on the hit, the trace length on the homonymous variable, and the trace direction will be the cross product from the impact normal of the result and the absolute up vector. Now with the outputs, promote the distance to a local variable called Right Edge Distance and create a branch on Close to Corner. On the true statement, connect it with a new function called Set Trace Hit Point. This function will have a hit and a new impact point as inputs. Let's go back a little and complete these functions. First with the trace corners. Start with creating a new function with the same inputs but with a hit result and Boolean as outputs. Make a branch on the bool, and on the false statement, make a return node without any connections. On the true side, return the offsetted corner point by multiplying the negated trace direction by a new variable called MinLedgeWidth divided by 2. This variable will have a default value of 30, then we sum all of this with the impact point of this hit result. The distance to corner will then be just the distance between these 2 hits, and the close to corner will be determined by whether this distance is less than the minimum one. Let's now deal with this function. Break this hit result and do the cross product between the impact point and the trace direction. Redo the cross product with the impact point and multiply it by the trace length after normalizing it. Then add this to the difference between the impact point and the normal and create a line trace component node. The start of the trace will be the vector we just found. The end will be a lerp between the difference between the impact point and the normal, and this vector with an alpha of 1.5. I'm going to activate this show trace boolean. This is purely for showing you how the trace system works, so feel free to leave this on false. Now we can concentrate on our second function. As the name says, we just have to set the impact point of the hit result gave on input. We can finally return on the main function. Create another trace corners function and use as inputs the hit, the cross product between the up vector and the impact normal, and the trace length respectively. Make a branch on the boolean, and on the true statement verify if the distance to corner plus the right edge distance is less than the minimum ledge width. On the false statement, use the set trace hit point function to set the hit's impact point as the offsetted corner point. On the true statement, however, we're going to do another function called trace width, with the hit and a direction as inputs and only a bool as an output. This function is going to take the hit result and the cross product between the up vector and the impact normal as inputs. Then make a branch on the output. If true, redo the function, negating the input vector. If false, return nothing. Finally, make another branch on this output and connect the false execution pin to the empty return node. Let's create the outputs for our main function. There's going to be 6 outputs, 2 booleans and 4 vectors. The booleans will be has front ledge and has back ledge, while the vectors will be front ledge location and normal, and back ledge location and normal. It's time for completing our trace width function. Use a line trace component with the hit component of the hit result as a target. Then for the trace start, get the direction times the min ledge width divided by 2, and sum it to the impact point. Sum it again with the impact normal times a new variable called min front ledge depth with a default value of 35 and connect all to the trace start. Do the difference for the end. I'm also going to activate the show trace boolean again. As I said, you can skip this part as it is only to show you the trace mechanism. We can finally return to the main function. On the second execution pin of this sequence, create a trace along hit plane function with the hit, the up vector, and the trace length as inputs. Make a branch on the bool and on true cache a new local variable called start ledge as the returned hit's impact point, else return nothing. Now for the final part of this function, do a line trace on the hit component with the impact point as tracing, and this vector minus the impact normal times the trace length. Cache this boolean as a local variable called has back ledge and do a branch on that. On true, cache another local variable as the hit normal and call it back ledge normal. Then do a trace along hit plane and use the trace length and the up vector as inputs. The out hit will be our back ledge location. Now we can return the outputs of our function. These will be always true for the has front ledge bool and the start ledge and start normal variables for the corresponding outputs. Then the has back ledge boolean for the has back ledge output and back ledge location and normal for the corresponding outputs. For the final step, let's reopen out try traversal action all function. Set the members of the traversal hit check. The members we're going to modify are all the members from has front ledge to back ledge normal. Expose them and connect the corresponding outputs. On this part of the function, I actually realized that this node is a minus, not a plus. Also on the trace along hit plane function, the first input for this cross product is the normal, not the impact point. Sorry for the mistake. Now you just have to place this try traversal action all function in the main try traversal action using this hit result and the traversal check result variable as inputs. Et voila. Now your character can mantle, climb, or vault on any surface. You can also see the traces being shot. I really hope you enjoyed this video and found it useful. I encourage you to leave a like and maybe follow my channel to get new Unreal Engine tutorial every week. This said, see you next time. Bye.